This is a demo of a system based on the SenZip architecture. We'll run an experiment for data gathering with distributed end-route compression and centralized reconstruction. These are 10 T-Mode Sky devices with onboard sensors. They measure ambient temperature, and to introduce some gradients, we'll switch these lights or heat sources on and off. The data is routed to a base station that is a moat attached to this laptop. This is an illustration of the setup and the routing tree, which is fixed for the purpose of this experiment. Let's get the experiment started. Now the routes are set up. Now the lights blinking there show that they've started measurements, and the nodes make measurements every 2 seconds. When they have enough to fill a packet, they forward them to the parent in the tree. The parent performs the transform. In this experiment, it is DPCM, and so the coefficients are differentials of its own measurements and that of the children. The coefficients are then encoded. We are using a Gullum-Rice encoding. This is when the actual compression or reduction in bits happens. The base station performs the reconstruction. These are plots for each node in the network. The x-axis is time and the y-axis is the temperature. The yellow line is for the raw measurements or the ground truth, and the pink line is for the reconstruction. We can see that the pink line takes time to catch up because of the extra delay due to compression. We have to wait long enough for the encoded bits to fill a packet each time. And really now the pink line and the yellow line are on top of each other because the reconstruction is so good. This is a replay of the reconstruction for one particular node, node number 7 in the network. And we can see here that whenever the gradient of the temperature is very high, then the error is also correspondingly higher. Gradient settles down, again the reconstruction is really good. The other metric we look at is the cost for doing data gathering. This is a plot for the number of packets or bits for each of the nodes. Y-axis is the cost in terms of number of packets, and x-axis is time. The red line is the cost for raw data gathering, and the green line is for the cost with compression. And we can see here that the gains improve with increasing hop distance from the sink.